Okay, I have 6:29, so I was waiting a minute. Oh, it's 6:30. We're good. Hi, everyone. Good evening. Thanks for tuning in. And happy St. Patty's Day, by the way. I'm Deb Weitzel, and I'm a member of the Friends of Pheasant Branch Board and also the chair of the Education Committee. I'm also a member of the city's Sustainability Committee, and together we co-sponsor these events with the City of Middleton's Public Library. So welcome to the Friends March Conservancy Day presentation. Tonight, we're pleased to have retired stormwater consultant and former Friends board member, Jim Bachhuber, to discuss Pheasant Branch Creek and its watershed, as well as the infamous rain event and flooding of 2018. Okay, my down button isn't working. Just a minute. Okay, Jim, you're gonna have to do the plan B.
All right, why don't you go ahead and finish your intro and I'll get mine set up here.
All right, thank you. I have a Mac and Macs have problems. Okay, so before we begin, I'd like to start by reading our land acknowledgement. Our organization recognizes that the land where Pheasant Branch Conservancy is located is the traditional territorial land of several Native peoples, including the Ho-Chunk. In the spirit of the Native peoples, we continue to discover and acknowledge the gifts the earth gives us. We cannot just take these gifts. We must give back by making the places we touch better than how we find them. We have no planned presentation for April. We invite you to join other community events celebrating Earth Day. The city will have a hazardous waste collection event on April 23rd from 8 a.m. to 12 p.m. at the Clark Street Community School parking lot. The May 12th, 6:30 presentation will be in partnership with the Sustainability Committee and their Sustainable You series. Bob Lindmeyer will give a presentation on climate change with registration available on the Middleton Library website. The Friends' next Conservancy Day event will be on Wednesday, May 18th at 6:30 at the Conservancy parking lot on Pheasant Branch Road across from Middleton Hills. So face to face, not a Zoom. We will be joined by Drew Cashman and members of Madison Audubon's Bald Eagle Nest Watch with spotting scopes to check out our eagle family that's in the Conservancy. So please note, after tonight, future presentations sponsored by the Friends will be on the third Wednesday of the odd numbered months. Stay tuned to our website and social media for more information. And now, just a reminder for some housekeeping. First, this presentation is being recorded. It will be posted on the Friends and Library YouTube channels. Secondly, comments and questions will be handled during the Q&A period at the end of the presentation. So please put your questions in the chat section at the bottom of your screen or raise your yellow hand, which is found in the reactions at the bottom of the page. Finally, there will be a survey at the conclusion of the Zoom to provide feedback on this talk and future Conservancy Days or Sustainable You topics, and that will be sent out tomorrow for those of you that are on the Zoom. With that being said, I will now hand it off to Jim to introduce himself and his talk, Pheasant Branch Creek. Where does all this water come from? Thank you.
Okay, thanks, Deb. I assume my audio is coming through okay?
Yes.
Yeah, okay, great. All right, well, thank you. Well, thanks for all the participants here tonight. As Deb said, I've spent most of my career working in water resources, stormwater management, water quality for both DNR and private sector. Throughout that career, I have given a lot of presentations to a lot of different audiences and groups about water resources and storm and pollution and water quality. And watersheds are kind of the building block of all these activities, all these phenomena that go on when we talk about our water system. And oftentimes I find after giving that talk, there's still some uncertainty about what exactly a watershed is. It might seem fairly basic to a lot of you, but for a lot, it's just not a concept that's always that well known. So I'm going to run through a presentation here. I hope to be done in about 35 minutes, and we can then have a Q&A time. And let me assure you that as I leave this slide. No children were harmed in the making of this presentation. So here's what we're going to cover. We're going to cover what basically what a watershed is, and I'm going to walk you through a series of slides on that. We're going to talk about rain events and how we measure and discuss rain storms, and then particularly talk about if you were in the Middleton area at all or west side of Madison, August 21st, 2018 rain event that if you were here, you will remember that. And then talk about the impacts. And so now what? Now what do we do about this new condition that we're in? So first things first, let's talk about watersheds for a second and just define what we mean when we say watershed. It's got a fairly simple definition if you just take it as an area of land that drains to a common point, a surface water to a common point. There are groundwater watersheds also beneath the ground surface. We're not going to talk about that tonight. We're going to stick to water on the surface. Basically, any lake, wetland, river, creek, stream, channel, any body of water has a watershed. I'll go through a little more detail on that in a minute, but let me get my terms also defined. We sometimes in the business, we use different terms when we talk about watersheds or drainage areas, and we use these catchments and basins and drainage basins. Well, for tonight, let's just say I'm going to use these terms interchangeably so that it all means the same thing. They're all defining an area that drains on the surface to a common point. So we can think about a watershed in very simple terms as being tiny and very small. Simply, this funnel can represent a watershed. The rim of the funnel represents the edge of the watershed. Water that falls inside that rim flows down to the outlet, to the funnel's discharge point. Water that falls outside of that rim simply goes to a different watershed. It's a very simple example, but I think it kind of gets the point across that anything inside goes to one point, anything outside that rim goes to somewhere else. So watersheds can be tiny like this funnel, or they can be huge, represented here on this map showing the watershed, the drainage basin for the Mississippi River. Mississippi River covers about 40% of the continental US, but the watershed itself. All the water in this highlighted area flows across the surface into various channels, rivers, and systems to the Mississippi, and eventually makes its way to the Gulf of Mexico. So anything going on in anywhere in this watershed can contribute water chemistry, water quality, water conditions, hydrology, hydraulics to the Mississippi River and to the Gulf of Mexico. What I want to do here is kind of work our way up the river system and work on smaller and smaller systems. Please check your mute. Someone has a microphone turned on. I can hear that in the background. Thank you. So if we work our way up the river, up the Mississippi River, and come to a place near the Quad Cities, Davenport, Moline, Rock Island, up between Illinois and Iowa, we come to a place where the Rock River enters the Mississippi River. The Rock River is a watershed. It's a drainage area that contributes runoff to the Rock River system. The headwaters of the Rock River is way up just north of a pond in Wisconsin. Flows past Beaver Dam, Watertown, Janesville, Beloit, leaves Wisconsin, enters Illinois through Rockford and down to the Mississippi River. So we've got a watershed within a watershed here. The Rock River is one of the watersheds within the Mississippi River basin or Mississippi River watershed. Let's work our way up the river some more. We're going to come to a point just north of Janesville in Wisconsin on the Rock River. When we get to that point on the Rock River, we are at the location where the Yahara River watershed and the Yahara River itself discharges into the Rock River. So the Yahara River is a tributary to the Rock River. Yahara River's headwaters begins in Columbia County, just east of Lodi a little ways. The bulk of it goes through the central part of Dane County, including all the Madison lakes. And that Yahara River discharges through near McFarland, Stoughton, and eventually enters the Rock River just north of Janesville. We're going to take one more step here up the Rock River. We're going to go work our way up into Lake Mendota and over to the west side of Lake Mendota, where we are. And what we find there, of course, is the Pheasant Branch Watershed. The Pheasant Branch Creek, or Pheasant Branch itself, discharges to Lake Mendota and drains an area west of Lake Mendota, about 23 square miles. This is the boundary of the land that discharges water into the Pheasant Branch Watershed in the Pheasant Branch Creek. I'm going to spend some time kind of exploring Pheasant Branch Watershed itself. Again, the red boundary is simply the divide between what water can run off into Pheasant Branch and what water would run off into a different creek or river system. The watershed itself can be kind of looked at as three areas. The northern part is the rural part of the watershed, up here by Ashton and north of Middleton. It's mostly rural landscape, and it discharges into a branch of pheasant called the North Fork of Pheasant Branch. Middle area of the watershed covers a good part of the city of Middleton, and the south area of Pheasant Branch Watershed is in the city of Madison, the west side of Madison. If you can kind of see the red line here going up, this is the belt line or Highway 12 going up to the middle of the watershed itself. Pheasant Branch Conservancy is over here on the east side. The creek does run through the Conservancy, and we're going to look at that in more detail in a minute, and gets into then to Lake Mendota. So let's look at some areas around Pheasant Branch Watershed just to get yourself oriented a little bit better. I just want to mention again to remind you that anything outside the red boundary goes somewhere into a different watershed. For example, Black Earth Creek watershed is just to the west of us. So there's a divide here that when rain falls, part of the across this line to the west is Black Earth Creek, to the east is Pheasant Branch. So let's look at some areas within the watershed itself just to get oriented. I'm going to start up here in the north. Up here I'm on a road called Riles Road up in the rural part of the watershed. If you were on Riles Road and drove across a culvert where this number 1 is located, you wouldn't see a lot, frankly. You would see simply a grass waterway in a cornfield. I'm looking north from Riles Road, and it enters a culvert under the road and enters and discharges to the south. That's the headwaters. It's dry most of the time. It only flows when there's a rain event going on or snow melt. And this is the headwaters of the North Fork of Pheasant Branch. You wouldn't even maybe even notice it if you're driving by in your car. Let's walk down to the southern part of the watershed, the very south. We're in the city of Madison here, right along the belt line at the intersection of the belt line and Mineral Point Road. And this is an air photo of what we see at that intersection. If you've ever been down that area, of course, you know where Target is, you know where Menards is. There's a stormwater pond right at that northwest corner of that intersection. And that, in effect, is the headwaters of the South Branch, of the South Fork of the Pheasant Branch, I should say. The pond has an outlet structure. It goes underneath the belt line and flows as a channel to the east and eventually to the north. If you look at that channel from the ramp, from the on-ramp going north on the belt line from Mineral Point, you don't see a lot. Again, it's a small little ditch behind, that's the Rocky Rococo's and shopping center area there along Mineral Point. So again, these start as very small water bodies, but they pick up water as they move themselves through the system and get to the more central part of the watershed. So let's look at an area in the middle of the city of Middleton, right here just west of the belt line and north of University Avenue. Let's look at an air photo here. This is an area where the two branches come together. So over here, if you can follow my cursor, we have the North Fork coming in from the rural area of the watershed, past the airport, underneath Airport Road, and it enters into this large green detention area between Deming Way and Costco, just west of US Highway 12. The South Fork comes across Highway 14, through the Middleton commercial area, and also connects up right here in an area that we call the Confluence Pond. This Confluence Pond is a built detention area. The city purchased the land and built this, I think 2002, if I remember correctly. It was built to help capture water and control flooding downstream in the channel system of Pheasant Branch itself. So the outlet to that Confluence Pond flows under the Beltline and Parmenter to the east. And eventually we're going to follow this strip, goes into underneath Park Lawn, Century Avenue into the Pheasant Branch Conservancy itself. Let's take a look down in that area finally. This will be the last stop on the tour. So here we have the area of Century Avenue. You see Allen Boulevard here and Branch Street. The old common ground used to be here. It's now being redeveloped, of course, but Pheasant Branch flows to the north here underneath Century Avenue, west of Branch Street into the Conservancy itself. It does a 180 in the Conservancy and turns around and comes back out here, crossing under Century Avenue again, east of Allen Boulevard, and then discharging into Lake Mendota. So that's the whole route of where we are in Pheasant Branch and the watershed. I hope these pictures, I hope kind of drive home kind of some of the areas that anything that goes on within that watershed in those areas we just talked about, whatever on the ground gets into the channel, into Pheasant Branch, and eventually into Lake Mendota. So we oftentimes see these dirty piles of snow this time of year. Well, that snow shows the dirt very well, but that dirt on the road is around all year round. It's not just a spring phenomenon. That's the stuff on the road that comes off of our cars and asphalt and concrete and all the other litter and material that's on the road. And that washes into the channel system and into our Lake Mendota, along with anything else on the ground, salt, leaves, nutrients, dumping stuff in the storm sewer itself. It does not get treated. It goes right to the creek, oil and other types of pollutants on the ground. So all this material ends up in our water system. Now I want to just spend one more minute on this part, and that is I want to point out that City of Middleton has done a lot of infrastructure construction to try to reduce flooding and try to reduce pollution in our stormwater. This map is showing some of the major ponds or detention basins that have been built by the city. South Pond is just here, just south of Highway 14. And we just saw the Confluence Pond. There's a Donna Drive Pond, we call it. That's behind the police station. You can't see that unless you drive back in the parking lot, back of the police station. Tribeca Pond is under construction or will be under construction this year. It's not built yet. And Middleton Hills Pond over in the Middleton Hills area on Frank Lloyd Wright exists. I pointed out Esser Pond here. Esser Pond was not built by the city. It's a natural kettle or depressional area wetland kettle, but the city has done some reconfiguration of that area to try to route floodwater into Esser Pond to try and reduce flooding in that area during high rain events. The other thing I'll comment quick on is that people sometimes aren't clear that Tiedemann Pond and Stricker's Pond are not part of the Pheasant Branch watershed. Those ponds are kettle ponds also, although there is a storm sewer that goes from Stricker Pond into Tiedemann Pond underground to allow when Strickers gets higher to flow into Tiedemann. Water from Tiedemann has to get pumped out. There's a new pump station right along Park Street there that the city owns and operates. And that pumps water through a storm sewer system into Lake Mendota. But again, does not get into Pheasant Branch watershed. So let's talk about that. That's the end of the watershed tour for now. Hope you enjoyed that. But I want to talk a little bit about rain events and how we define rain, and then get into the August 2018 rainstorm. We hear these terms all the time on TV or other places, these 10-year, 50-year, 100-year rainstorms, and it's To me, it's been a poor choice of terminology for most of my career because it does cause confusion. People assume this means that it's a frequency of how often they occur. In other words, it won't occur for another 100 years. But really what this is simply a calculation, a statistical analysis of the chances of a rain event occurring in any one year. So a 10-year event has a 10% chance of occurring in any one year. 50-year event has a 2% chance. 100-year event has a 1% chance. But as we know, and as we've seen, you can get a 50-year or 100-year or other larger events in several years in a row. It just simply has a 1% chance every year of occurring. The other thing I want to just convey to you is that when we talk about rainfall data or rainfall storms and define them, there's two things that really need to be known to actually define the severity of a rainstorm. The duration of the storm, in other words, how long did it rain? When did it start and stop? Was it 2 hours, 6 hours, 12 hours, 24, or something else? So the duration of the storm and the amount of rain, the depth of rain that fell over that time period is what defines our rainstorms. So we can have, for example, a 10-year 2-hour storm, a 10-year 6-hour storm, a 10-year 24-hour storm, etc. And each of those rainfalls has a different amount of rain associated with them. I'm going to show you what that is right now. So National Oceanic Atmospheric Administration, NOAA, develops this data and does the analysis and calculates rainfall reoccurrence intervals for certain rain durations. So you can see on this little table here for the Middleton area, by the way, NOAA does this for all over the all over the US. So each area has a little bit different numbers or values for these rainfalls. So for example, the 10-year 2-hour rainfall is about 2.45 inches according to this data. 10-year 24-hour storm, which is a longer time period, of course, it's a 24-hour period, it has 4.10 inches of rain. So it makes sense that the longer the period of rain, let me go back, and the less frequently the rain might occur, the larger the rainfall event itself. If you're thinking to yourself about, well, let me just clarify that this data is based on the historic rainfall conditions that have been measured in Madison, West Madison, Middleton area. And as we know, things have been changing and things need to be updated. And these statistics we're finding that they're not representing current conditions anymore. But let's just talk a little bit about what did happen on this August 2018 rain event. And I'm going to talk in more detail about this. This is a radar image from one of our local TV stations that I grabbed off a screensaver. It shows a radar image of that rain event. And to orient yourself, here's Madison, here's the belt line, Highway 12, this yellow line, and then here's Highway 14. And you can see right about here is the central part of the city of Middleton, is the brightest color. And the brightest color on this scale says only 7+ inches of that's as high as this scale went on this radar image. Well, it just so happens that at that location where I'm pointing, there's a United States Geological Survey rain gauge. It's been in place for many, many decades. And it measures rainfall on a continuous basis. So it measures rain over time at that location. If we look at that particular rain event, the August 2018 rain event, this is the only chart we're going to look at tonight. So hopefully we can deal with this. The chart is showing along the horizontal line here, a time, date and time. And under the vertical axis here, we've got precipitation in inches. And the blue line just simply shows the rain accumulation on that rain event. And you can see the rain started around 3 p.m. in the afternoon on August 20th. And when the blue line goes vertical, that means it's raining very hard and we're getting lots of rain over a short period of time. When it flattens out, the rain may have let off a little bit And so we got less rain depth accumulating over that period of time. It rains hard again. It backed off a little bit. It rained hard again. And then finally, it ended somewhere around 3 a.m. So that's what was measured at that location on that date. It's about a 12-hour period. And in that 12 hours, the total rainfall that fell at that location was 10.56 inches. I should have told you a couple of slides ago when we were looking at the table about those rainfall depths, 10-year storms, 100-year storms in durations, 2, 6, 12, 24 hours. There it is again. Those numbers, how do they compare to what was measured on August 2018? Well, you look at this and you see that the 12-hour storm, which is about what we had on that date, according to the statistics, according to what NOAA calculated, is about 5.9 inches. We received 10 inches. If you continue these calculations out, the statistics show that even a 1,000-year reoccurrence interval, 0.1% reoccurrence interval, which is a very, that's as far as the scale goes, was calculated to be 8.92 inches. We're still less than what was measured at that USGS site on August 2021. So truly that rainfall was off the charts that we experienced. It's something that had not been measured before in this area. And I hope that gives you some idea of the magnitude of what that event was. This is another way to look at the event, and I want to just show the variability of rainfall. This map here was developed by Dr. Dan Wright at the University of Wisconsin Engineering Department. Using rain gauges throughout the watersheds and radar data, he plotted the rain depths of that storm, the August storm, in Middleton, West Madison, and Western Dane County. And you can see the darker colors, brighter colors. This red represents 12 to 15 inch depth, which is what, and the brown is the 9 to 12 inch depth. And in fact, the rain gauge here at the USGS measured at 10.5 inches. So it's showing you where the heaviest rain fell geographically, West Madison and Middleton. But if you move east, move into the campus area, the rain depths quickly fell off. The storm did not move across that way. So if you're in downtown Madison or campus, you saw maybe 1 or 2 or 3 inches of rainfall. And I point this out because, people love to have rain gauges in their yard, and we like to measure how much rain we got. And somebody 2 miles away may have measured X, and somebody in your neighborhood measured 10X or 2X or something else. It just shows you how variable that rainfall can be. When we talk about how much rain did you get, you got to ask the question, well, where are you, to know how much you got? You may not be the same thing. So that's something I wanted to point out. So, okay, so we had a lot of rain. When I get a rainstorm like that 10 inches of rain, 10.5 inches, what happens when this rain hits the ground? Well, some of it soaks in a little bit. Some of it is held up in depressions, puddles, kettle ponds, our stormwater basins, etc. But somewhere in the range of 70 to 90% generally, depends on a lot of conditions, the intensity of the rain, how dry the soil is, if the vegetation is in leaf or not in leaf, all kinds of factors. But somewhere in this range of 70 to 90% runs off the surface. And the question becomes, well, how much water was that? How much rain ran off during that August 2021 event? If we do some simple math, let's just take the area of the watershed, 23 square miles, 10.5 inches of rain, and let's just take the middle spot. Let's just say 80% ran off during that storm. What does that calculate out to be in terms of a rain volume or a water volume? Well, the number is a ridiculous number. That number is 3,367,166,420 gallons. I don't know about you, but whenever I hear about this kind of stuff and how much water fell, kind of makes my head explode. I can't wrap my my brain around this kind of a value. Hope you don't mind my Seinfeld reference here, but I couldn't help myself. So let's try to put that in a little more perspective. What does that number mean? Well, maybe this will help a little bit. If we took a football field, including the end zones, and just stacked it up in a big rectangle on top of that football field, that number of gallons, that 3 trillion gallons, would fill a rectangle about 7,800 feet high. That's the amount of volume that came off in that one rainfall event. That's the amount of volume we're trying to carry through this channel system and our land through Pheasant Branch and out to Lake Mendota. Thanks to my friends at Middleton Park and Rec, they gave me the volume of the Middleton swimming pool. That volume turns out to, of the rainfalls, about 9,732 Middleton pool volume of water. So I guess hopefully the message is it's a lot of water. And when you try to shove that much water through a system, some bad things happen. And I'm going to show you some pictures now of what was going on the day after that rainfall of August 21st. This is a picture taken from Century Avenue on the bridge west of Branch Street. So I'm just west of the old Middleton grounds, common grounds place. And I'm looking south. So I'm looking what would be considered upstream. If you follow that channel far enough, you would get to Park Lawn crossing. On a normal flow day, the left picture, the creek is in the range of 10 to 15. We have another unit of measurement here, cubic feet per second. Every second, about 10 to 5 to 10 in that range, depends on the day, flow going by that bridge on Century Avenue, looking south. On the morning of August 21st, I was out there from that bridge. It did not overtop the bridge, but this is what the flow looked like from the same angle. I hope you can pick out these trees are the same. This flow is measured at 2,660 cubic feet per second. And that's the result of having 10.5 inches of rainfall come in 12 hours in the Pheasant Branch watershed. Some more pictures. This was taken at Park Lawn, looking west, so looking toward Parmenter. Here it is during normal flow times. Here we are on August 21st at about 7:30 a.m. Again, there's a lot of water. It did not overtop Park Lawn to my knowledge. It did back up quite a bit and caused quite a bit of damage in the corridor itself, of course. And this is a picture on the other side of Park Lawn. You probably all saw this if you walked around it all after the storm. This was taken a few days later, of course, when some cleanup work was going on, but gives you a scale of the erosion that occurred on that bank on the east side of Park Lawn in the channel itself. That's the north bank. I'm going to show you another view of another area of the watershed. We're looking at the Confluence Pond area. I hope you can orient yourself again. Here's Highway 12. Here's Spectrum Building, Fiskars. Here's the channel leaving that Confluence Pond during normal flow. You can't really see the channel very well, but it goes under a footbridge here on the bike path underneath the belt line and to the east then. And here's what this same shot looked like, courtesy of the Middleton Fire Department's drone that they flew that morning of that same area. And the amount of water that the pond was holding all it could, and in fact was overtopped. And as you know, we had flooding on Deming Way, we had flooding in the Costco area and this area to the south on Discovery Drive, etc. It just kind of gives you an idea. I'm going to go back just to show you again what it looks like during normal times, and then what was happening on that morning of August 21st. Another place, just one more shot of some of the flow, and then the aftermath of it was this. I'm sitting on, I didn't take this picture. Actually, I don't know who took this picture. It was given to me by another Pheasant Branch member, but we don't know her. If you recognize it and you took it, please let me know. I'll give you credit. But this is the railroad track that parallels Highway 14 to the south, right by just west of the Mounds Pet Food Warehouse area. And that morning or that night after that storm, on the other side of that track, of that trestle, that railroad track, is South Pond, the South Pond stormwater pond basin. That overtopped and blew out the railroad bed itself and left the train track just hanging in the air. And that was the damage from that same event. And then, of course, in the corridor itself, we've probably all seen the work that the river did and the damage that it caused throughout the corridor. So what are we doing about it? What can we do about it? There's really, there's no easy solution. Some cities are designing infrastructure for larger rain events. So bigger ponds, bigger storm sewers, larger channels that are armored, more ways to carry that water without causing damage to property or endangering human life. Many cities are looking at more regulations for when new land gets developed, when you convert land from a cornfield or grassland or whatever to a subdivision or commercial property. You are simply covering up that bare soil, that open soil, and causing more runoff to occur. And there are regulations that say how much water must be retained on your property if you're going to develop it. Well, many cities, including Madison and now Middleton, are looking at upping those regulations to require more retention on property when it gets developed. Madison adopted a new ordinance about 2.5 years ago. Middleton is right now in the process of looking at upgrading our ordinance also. Create areas of temporary storage areas. Where can we park this water? Well, it won't cause property damage or harm. Athletic fields, playgrounds, open space, or maybe we just have to remove structures from areas that are flood prone, and we'll be getting more and more flood prone as time goes on. All this, of course, costs money, and the biggest issue, the biggest challenge is, well, how much do you want to spend for an event that you don't know how frequently it's going to occur, when it will occur, and in what size it really will be. We have all the statistics, but we know things are changing. We know we have to try to prepare better for future flood conditions. I actually got through this much quicker than I thought. I hope I didn't go too fast. I'm going to open it up to questions, and if we have any French majors in the crowd here tonight, you can translate that sign. I even take pictures when I do my traveling. So that's the end of my presentation. I'm certainly available for questions and discussion.
Okay, we do have some questions. Being that rain events are producing more rain over shorter time, what could homes and businesses in the watershed do to capture and keep more stormwater on their property?
Well, yeah, that is the several $1 million question, or even more than that. I mean, that's exactly what the regulations are looking at doing, the city ordinances that are being considered, as I said. There are people building lots of, self detention basins themselves, rain gardens, green roofs, anything you can do to remove pavement and add vegetation incrementally helps a little bit. There's no one solution that's going to take care of this issue. It's going to be many, many, many small solutions that have to add up and have an impact.
Okay, thank you. Martha asks, why was the Middleton Hills Pond dry in 2021 and 2022?
I live right across from that pond, so I'm on Frank Lloyd. Yeah, well, again, that is just the variability of it. I mean, we had some dry years. I don't know this for a fact, but I think some water does seep out of that pond, not through the surface, but just soaks into the groundwater. So I think if you don't get rain, that water, well, it evaporates for one and soaks into the ground for two. And yeah, we had a couple of years there where there was no water at all. and last year was one also that we didn't have water. So I think it's just a combination, again, the climate conditions and evapotranspiration.
Okay. Kermit wants to know that while the extreme precipitation event is totally consistent with Wiki and other climate projections, was there a formal analysis of the 2018 floods correlation with climate change? And if so, what did it show?
I'm going to have to defer that to some other people. Dr. Dan Wright would be one. I think Dick Lathrop's on this in this crowd somewhere, and I wouldn't mind picking his brain on that question. The question was correlated with climate change is well, it's beyond my pay grade for one thing. Climate, of course, deals with long-term solution or long-term conditions and long-term changes. We had an event that there's plenty of evidence that we're getting more frequent and more intense rainfalls than we have in the past. And that is attributed to climate change. And the Wiki report talks about that. That somebody mentioned Wisconsin Initiative, Climate Initiative. I forgot all the letters, but
Wisconsin Initiative on Climate Change Impacts, Jim.
Thank you. I knew Rick would have it. So anyway, the point is to attribute any one event to climate change is challenging, is difficult, but the overall pattern, I believe, is more attributable and can be attributed to more of the climate change type of conditions that we're undergoing.
Okay. All right, I guess.
Dick Lathrop has his hand up there, Deb. Let's see what Dick's got to say about this.
Yes, you do. Thank you. Go ahead.
Okay, well, Jim really pointed the key thing out, the statistics upon which we base all our frequencies of rainfall events and flood flows and things like that are all based on the historical situation for the past 40 years, say from 2000 or even earlier backwards. And so with climate change, we're just seeing more rainfall on an annual basis. And then also we're seeing that the size of the events is getting bigger and they're occurring more frequently. So that changes all the rainfall statistics like Jim has mentioned. And as long as I got the floor, can I address another question that somebody has raised about why was Lake Mendota so high and all those issues? Well, the solution to that has been, and the county is doing what they need to do. It's not just the dams, it's they're dredging out the channels so water can flow more freely through the whole system. And Lake Mendota couldn't get rid of its water. The Tenny Park Dam, they can raise the Tainer gates up and they can blow all that water downstream, but they'll flood the complete isthmus and farther downstream. So to the county's credit, they have been dredging the river channel and segments, and they're going to be able to move water faster through the whole system. And therefore, Lake Mendota can be in a more normal range when we have this kind of event. But back to Middleton, 11-inch rainstorm, way beyond anything, as Jim said, we've experienced. So how do we prevent some of this? Well, we really have to be looking upstream and figuring out ways to store more water, at least detain it. And Jim mentioned the Esser Pond and the South Pond. And maybe Jim can comment because he is on the Water Resources Management Commission. I think there was a report that came out about a year ago on various solutions and opportunities. And there's quite a bit of opportunities in the South Fork, not so much in the North Fork. It's in farmer lands and it's all natural and it would be hard to do a whole lot up there. But the South Fork has the South Pond and actually some opportunities that haven't necessarily been agreed upon for increasing the temporary storage in Esser Pond. So maybe Jim can comment on that.
Yeah, well, thanks, Dick. Yeah, and I hope people realize Dick's on the sustainability committee, right, for Middleton, and also
Yes.
retired professor at UW. So I respect a lot what he, the information he provides us. So the city is looking at every opportunity to maximize storage in these larger ponds and basins throughout the watershed and finding new ones. The hard fact is, I hope I don't, ruin anybody's night, but if we get an 11-inch or 10.5-inch rainfall in 12 hours again, the stuff we build is not going to prevent flooding on that kind of rainfall event. We're trying to manage rainfall events that are in the 5 to 6 to 7-inch rainfalls. And even that is going to be very, very, very expensive to accomplish. Middleton is looking at all areas of the watershed, including the north side, the North Fork, and just looking for potential for areas for storage, for ponds, for basins, for acquiring. And again, as I said, all this is incredibly expensive, and it's going to come down to, well, what will the taxpayers bear? What will they allow to fund these measures, this infrastructure? The longer we get away from a rainfall like August 2018, the less and less urgency there is, to manage these systems. There's a cycle that after these rainfall, everybody wants to fix it and never let it happen again. But as the years go by, it becomes less and less of a priority for in many cases. So that's just kind of human nature.
Okay, you had a very large amount of water that you had on the screen back a ways. And someone is saying, isn't it billions, not trillions of gallons?
Did I get the wrong units there? I think you're right. It was billions. Yeah.
Okay.
Yeah. Thank you.
Like
Thanks
that.
for the catch.
Jeff, okay. Following the bad flooding in August of 2018, it was revealed that Lake Mendota and maybe the entire Yahara River watershed may have been artificially high because dams on it were keeping levels high for recreational boaters. If that is true, what was done, if anything, on August 20th and immediately after to minimize the flooding to Middleton, West Madison, and on the Isthmus? And also, do you know if decision-making processes have been modified since?
There's a lot packed in there. I'm trying to see how to respond to that. Dick Lathrop described how the lake levels that occurred at their rainfall event simply physically could not get drained, regardless of what the Mendota level had been. They couldn't be drained in a quick manner because of the slope of the water downstream into Lake Monona, and then Wabeesa and Kaganza all the way down the system. There simply is not the funnel hole is not big enough to get the water out any more quickly than what they were doing. And as Dick mentioned, the county is now spending a lot of money on dredging and enlarging channels to facilitate that discharge rate in emergencies. As far as lake level management, that's a huge can of worms. If anybody likes to go fishing on the lake or boating on the lake, there's been controversy about what the appropriate lake level should be for the various users of the lake. That's a DNR sets those ranges on the dam at Tenney Park and the dam down at McFarland. And they set summer and winter elevations for the lake, but you can't always achieve those numbers because just what Dick Lathrop said earlier, you can't manage this lake like a faucet. You can't turn it on and turn it off. It takes a long time to get the lake drawn down 1 inch or 2 inches. It's a lot of water to get rid of. And so it's not a system you can fine tune like a plumbing system. I'm not sure I addressed all the questions that the person had, but that's the best I could do right now.
Yeah, can I just chime in? I hate to interrupt, but I just want to say what Jim was talking about. With the ability to get rid of water faster, they could prevent. The Lake Mendota was about 2 feet over its normal level when the storm hit. So the idea is to be able to drain the lake systems more proactively so that the lake is at its normal range when we get that kind of extreme event. So the lake levels themselves are pretty reasonable. I've been on 2 or 3 different Yahara Lake Advisory Group committees addressing lake levels. And the levels seem to be pretty reasonable. It's a question of maintaining them within that reasonable range. And I think being able to drain them faster allows the county to keep the levels more in that range when we get a lot of, say, late winter and spring runoff. And then so that the lakes are in a normal range when the big storm hits, and then we can get rid of the water faster too. But we got to remember the lake, the whole system was about 2 feet over its normal summer range when the big storm hit. So that's the problem. They couldn't get rid of the water fast enough prior to the storm, and then the storm hit. I think the county has actually got the right solution.
And if you remember that year, the county was trying to get the lake down. In June of that year, we had a pretty good sized rainfall then too. I forgot what it was, if it was 4 inches or 5, it was a good rainfall. So what I'm trying to say is the county was battling that high water from the beginning of the year, and they just couldn't get it down to the summer numbers they wanted to with the discharge rates that they were dealing with. The other quick comment I'll make is that when you saw that radar image of the storm that occurred, and why we got all that rain is that orange and red and purple blob didn't move. It came and it sat there and just dumped 10.5 inches. If that blob had been over Lake Mendota or to the east, let's say 3 or 4, 5 miles, the Madison lakes and the Madison itself would have been much more heavily impacted than what we did see, and only because of the location of that rainfall.
And just to the west of us, Cross Plains got even more rainfall.
Cross Plains, Black Earth.
State record of what, 15 inches, I think, something like that.
Yeah.
So, yeah. Okay, I just wanted to direct people to the chat. Lisa wrote that UW Arboretum is offering an Empower You stormwater training starting next month. And she has a link in there, which is to engage others in stormwater issues and watershed protection in their communities. So if you're interested, check out the chat on that one. Okay, next question from Lynn. What portion of the watershed is not developed? Did we learn anything from the 10-inch storm that could help guide us when there is pressure for development in these areas?
Well, the map, that I was showing today, pretty much anything north of, let's say, Schneider Road on highway, north of town here, is pretty rural, right? It's farmland. It's using crops. There are subdivisions, land development proposals going on right now north of Graber Pond and to the west of Pheasant Branch Road, between Pheasant Branch and High Road. That's undeveloped land right now. There are proposals in for developing those lands. It's a very controversial issue. There's the city is doing all it can to require stormwater management and maximize stormwater management on those developments. But the bottom line is every time you take a piece of property and convert it from cropland or grassland or forest to residential or commercial, you are going to have more runoff no matter what kind of management you do. So there will be more runoff on those sites under certain rainfall conditions. The challenge is, of course, does the city want to take a position of saying, well, no more growth. We don't develop land anymore. That's not a very popular comment to make. And it's a question for the council and for the elected officials to decide how much and where and what kind of development is going to be allowed.
Okay, well, this question kind of goes to that. What kind of mitigation is taking place in the new development areas upstream?
A couple of examples we're trying to do is require the developers to add more opportunities for water to soak in. So rather than having a larger single stormwater pond like we often see on some land development activities, have that pond, but also include more greenways, more grass areas, more opportunity for water to soak in throughout the planned development. That might mean things like grass swales, rain gardens, biofilters, things like that. So those are the mitigation measures that are being talked about and pushed now for new land development activities. And again, these are not bulletproof. They're not the silver. They're not going to resolve all runoff problems, all stormwater problems. They're going to chip away at it as best we can at these different locations.
So
Rick has his hand up. Oh, go ahead, Deb. Sorry.
Oh, I'm sorry. Go ahead, Rick. Oh, yeah. Your background is yellow and so is
Yeah.
Yeah, just a couple of things. So one of the earlier questions that was asked about climate change versus the 2018 flood event. Warren Giebert actually put together a really nice article that compared both, some of the projections of climate change from the Wiki initiative just released last November. So there's a link to that in the chat. And then also a couple of different questions of talked about what has been done in basically in response to the August of 2018 flood. And certainly there's been a lot of discussion that Jim and others have had on Water Resources Management Commission. A lot of great minds, at least giving thought to what could and should be done. City of Madison has really taken a huge initiative to develop detailed watershed studies throughout the entire city of Madison, and have already gotten, in the last 2 years, have already gotten through half of the watersheds with very detailed modeling and detailed recommendations for wet ponds, dry ponds, bioretention areas, basically a whole suite of different best management practices for stormwater. They're all getting documented, and then at some point, as money becomes available and funding is approved, then those improvements can hopefully come to fruition.
So Rick, what if homeowners, businesses use more native plants with the deep roots? Wouldn't that channel more water into the soil than, yard grass?
It would, yeah. In my opinion, it would. It's hard. You're not going to get 11 inches of rainfall depth into the ground and be able to be responsive to events like we had for August of 2021. So that's going to take a different suite of approaches, but everything that people can do right on their own properties is going to help incrementally, like Jim had mentioned before. And the more, especially on a volume control standpoint. Now, on a flood control standpoint, maybe not a huge impact, but on a volume control standpoint, that can really make a huge improvement, especially for areas that are closed watersheds, draining to a kettle pond. So that's definitely a huge benefit. Again, anytime that you can create more pervious surfaces and drain impervious areas to those pervious surfaces, you're going to have less stormwater runoff coming from those properties.
Okay, thank you. And that is the last question that I see here. So I thank everybody for coming. There's a couple of comments about excellent presentation. So wonderful presentation. So kudos to you, Jim. Thank you very much.
Thank you.
And also thanks to Liz Zimdars, who's the head of the library's adult services. She put all of this together, all the audio visual, and I thank her for that. And with that, I guess we are finished for tonight. So hopefully we'll see some of you or all of you back for our May climate change presentation or at the Conservancy to check out the eagles. Thank you.